Okay, so if you did not catch all the definitions, I'm going to slowly scroll through them. So you can pause the screen over the ones you need to do. Okay, we're going to do examples now. So example 1, finding rational zeros of x cubed plus x plus 1. We're going to do rational zero text. So let me remove this. Okay, let's work through this. So p is going to be a factor. P is going to be a factor of 1. Q is going to be a factor of 1. So both of these can be plus or minus, plus or minus. So what we do is we check. We're going to check. This is f of x. We're going to check with synthetic division. P over Q is going to equal either plus or minus 1 over 1. Okay? Or P over Q is going to equal plus or minus 1. Okay? So we have 1. Sorry, I do my synthetic division that way. Let's do it their way. 1, 0, 1, 1. So we go down 1, 1, 1, 1, 1, 1, 1. So this is not a 0 because this number's not correct. So let's try negative 1. We go 1, 0, 1, 1, 1, negative 1, negative 1. I'm sorry, this would be 2. This would be 1. This would be 2. This would be 3. Okay, negative 1 is going to give us positive 1 here. Sorry, minus 1. It's going to be 1. It's going to be 2. It's going to be negative 2. It's going to be negative 1. Okay, neither of these is zeros. So you could say is that this has no rational zeros. So remember, I took P from this number and Q from this leading coefficient, okay? Which was 1. Okay, let's look at another example. Keep going through this. Okay, let's look at the next example, which is f of x equals x to the 4 minus x cubed plus x squared minus 3x minus 6. Okay, so we look, p is going to come from 6, which is going to give us plus or minus 6, plus or minus 3, plus or minus 2, and plus or minus 1. Q is going to give us just 1, plus or minus 1. So if you have P over Q, so P came from this number, Q came from this number, and it will always be positive index. Okay? So this will give us plus or minus 6, plus or minus 3, because I'm just dividing 6 by 1, 3 by 1, 2 by 1, 1 by 1. 2 plus or minus 1. And my approach to this is generally start with ones and work this way, okay? If these numbers are low, you usually want to start with ones and then go bigger. You never want to start with bigger and then go smaller, okay? So let's start with 1. We have 1, negative 1, 1, negative 3, right? 1, negative 3, negative 6. Okay, so let's start with 1. This is 1, that's 0. This is 0, it's 1. 1 times 1 is 1. Negative 2, that is negative 2, that's negative 8. So 1 doesn't work. Now I'm going to try negative 1 over here. So we have 1, negative 1, 1, negative 3, negative 6. Okay, we get 1. 1 times -1, -1. Add these two together, -2. We get 2. 2 plus 1 is 3. 3 times -1 is -3. -3 plus -3 is -6. Times -1 is 6. 6 plus -6 is 0. So this is one of our zeros, okay? Now, we actually are going to use this with the next one. So let's go to 2, okay? So we went from 1, let's go up to 2, okay? So let's do positive 2, okay? And we have 1, -2, -3, and -6. Okay, I'm reaching over, so I'm going to scoot a little bit closer. Okay, let's go. So we add 1 down, times 2, 2, so 0, so 0, 3 is -3, add plus 2 is going to give us, oh sorry, this should be positive 3, that was my mistake. So that's 3, 3 times 2 is 6, 6 plus -6 is 0. So our last one's going to be 1, it's going to be 1, 0, 3, okay? So we found 2 of our zeros. So if we are, I'm going to erase this stuff over here. If you ever want to pause, you can feel free to pause. So our 2 zeros are x equals -1 at 2, and we're left with x squared plus 3. Okay? So if we were to write this out as factors, we would have f of x equals x minus x plus 1, x minus 2, because you always subtract it, okay? So you subtract the -1, that's plus, subtract the positive, you get a negative, and then you get x squared plus 3. Okay, so this is our factorization right here. And our zeros, our real zeros are these two, okay? Okay, let's try one last one, and then we're going to move on, okay? Let's go to example 4. Yeah, let's do example 4. Example 5 is the same way. If you just start with 0, it's going to work out the same way. So we have f of x equals 2x cubed plus 3x squared minus 8x plus 30. Okay, so for our p, it's going to come from positive -3, positive -1. Q is going to go from positive -2 to positive -1. So if you have p divided by q, again, p came from this, it's p, q came from this, okay? So divide it, we get plus or minus, 3 divided by 2 is 3 over 2, 1 divided by 2 is 1/2, and then 3 divided by 1 is plus or minus 3, 1 divided by 1 is plus or minus 1. Now you can organize this in greater to less, that's fine. But what we're going to do is always check with 1 first and then go on, okay? So we could check with the other ones. We could always check with bigger ones or smaller ones, but I like to check with 1 first. So you do 2, 3, -8, 3. Let's just check with 1 first. So let's go 1, so 2, we get 3, not 3, you don't add them, you time multiply. So 2 times 1 is 2, which becomes 5. 5 times 1 is 5. This becomes -3. -3 times 1 is -3. So you get 0. So our first answer, so we have x minus 1 is going to be one factor, times, what's our answer? 2x squared plus 5x minus 3. Now, guys, if you know how to factor this quadratic, please do. So 2 times, so we'll look at these two, that's -6, factors of -6. And if I was to factorize this polynomial right here, that would be just I could do it in my head. You can also do synthetic division. So if you do it in your head, you'll get 2x and x. So 2x is going to be multiplied plus 3. So 2x times 3 is going to be 6. And then this is going to be minus 1. And so your factors are going to be written out just like this. Okay? Okay. So what are our factors? Well, our factors are x equals 1, 1/2, and negative 3. Okay? There we go. That is going to be example 4. So I'll let you have example 5 to do by yourself. And we'll try to cover we'll try to cover 6 and 7 quickly. Okay, very fast. Okay, find a fourth degree polynomial with real coefficients -1, -1, and sorry, there should be a comma, and 3i. So remember, sorry, that's not zoomed in enough. Okay, so I'm actually going to just blow it up so you see this. This video might be a little bit longer. Apologies, everyone. Okay, so what we're going to do is we're going to write it in linear factorization. Okay. This way. Okay, so we have f of x is going to equal x plus 1 times x plus 1 times x minus 3i. And as we know, with complex numbers, they come in pairs. So x minus 3i, x plus 3i. And we're going to solve this. So if you solve this, what's going to happen? Well, you're going to get f of x equals, first is going to be x squared plus 2x plus 1 times x squared plus 3, plus 9, sorry. Okay, then if we multiply these two together, you get x to the 4 plus 11x cubed plus, what is this, 10x to the 2, sorry, 10x to the 2 plus 18x plus 9. Okay, that should be appropriately correct. Yep, that looks correct. So this should be plus 9. Okay, so this is our final answer. So if we were to write it out, f of x equals x to the 4 plus 11x cubed plus 10x squared plus 18x plus 9. Okay? Example 7 or 8, you can do the same thing. Just remember, first you are going to want to divide. I'm just going to give a quick explanation. Divide by, so you're gonna get, remember they go in complex conjugates, so you're going to divide the function by x plus 1 plus 3i. This is going to be minus 1 plus 3i times x minus 1 minus 3i. Okay, and that's going to be, you're going to divide by, what is that, x minus 1, if you solve this out, you're going to get x squared minus 2x plus x. Okay, you're going to divide by this. You're going to divide this by this, and then you're going to find the rest of the back. Okay? Okay, that's that. Sorry, just